packet, our season ticket revenue packet that you're looking at, gives us this situation. We have a community theater. They're currently selling 200 season tickets, $50 each. And they're considering raising their prices to see if it'll help them make more money. So they gave them a survey to a bunch of their season ticket holders and found that for every $5 increase in the price of a season ticket, they might lose 10 people. So they need to determine if they should raise their prices or keep them the same. They want to figure out how they can balance that. This right here is one of the very realistic situations of why I love quadratic equations. They're found in normal life all the time. It makes sense. If you're going to make a bunch of jeans and charge $10 for them, you're going to probably sell a lot of pairs of jeans. As soon as you make some pairs of jeans and you sell them for $80 each, you're probably not going to sell so many pairs, but you're going to make more money. So you have to find that kind of balance in between. Our first question asks us to create a function that relates the product of the number of season tickets. Product means to multiply the number of season ticket holders and the price of a season ticket. So here's our number of ticket holders. Here is our price. N is the number of price increases. So they're talking about doing a $5 price increase. And they might increase it one time, that's a $5 charge. They might have 2 price increases, that's going to raise it $10. They might have 3 price increases, $5 each, raising it $15. They want to see how many they should have. So let's think first of all about their number of ticket holders. What do they have currently right now to begin with? 200 ticket holders. What a fantastic answer. So you guys are going to be in on all the inside jokes on these videos too. 200, and for every price increase N that they do, are they going to gain people or lose people? They're going to lose people. So we're going to subtract 10 people for every price increase N. So we have 200 minus 10N. So revenue is this times price. What is our price currently at right now? $50. $50. For every price increase, is the price going up or down? Oh, that's kind of a funny question, isn't it? So we're going to add to it $5 for every price increase. 5N to it. Now these next couple of questions are kind of silly because we set ours up so brilliantly. Which expression represents the number of season ticket holders? Well, we already identified that. This part right here, 200 minus 10N. What units are associated with that? People. It's kind of weird, isn't it, to think like, I think it's people. It is. It's people. We need to not lose sight of this, that we're counting people. And then our expression for the price of a ticket is the other part of it, the 50 plus 5N portion. And what units are associated with price? Dollars. Loving it. So let's check this thing that we wrote. I think it's looking pretty good, but let's just check it. It's asking us to find the value of R0. So what is our revenue at 0? This revenue at 0 means that N equals 0. When N equals 0, this means no price change. I like to think of this stuff first and write myself a little note so when I finish my mathematics and I have a calculation and an answer, I can put it back into context. So when I have no price increases, no price change at all, I want to figure out what my statement looks like. I have 200 minus 10 times 0. I'm going to stop there and think about just this first part of season ticket holders. 200 minus 0 means we have 200 ticket holders. That makes sense. That's what they started us with, that we start with 200 season ticket holders. And we're multiplying it by 50 plus 5n, but they asked us to say, well, let's make that equal 0. So 50 plus 0 means $50 each. 200 people paying $50 each. What is their total revenue right now? $10,000. So we checked our function, we found what the value of R0 is, and it asks, what does this number represent? Let's write nice full sentences that incorporate what our answer is. 10,000 represents the current total revenue. So without any price change, we have 200 people. See how I'm incorporating the units right here? We have 200 people who pay $50 each for a total of $10,000. Nice. We're off to a rockin' start because we've created a great function, and we're going to see we're going to use this function again and again and again. So let's scooch down here and think about the domain of this function. Domain is usually telling us about our x value. It's our independent variable. Here, our domain is referring to what possible n values we can take. Okay, so domain is what values n can take. We're going to have some limitations on it. We can keep on raising prices infinitely number of times. We can just keep on, well, it's $1 million for a season ticket. It's $1,005,000 for a season ticket. We can keep on going as high up for price as we want to. But something's going to happen on this other side when we think about season ticket holders. All right. So since the n is the number of price increases, it might just be the set of whole numbers, but there is something we have to think about. Because each time we raise prices, we lose customers. What's eventually going to happen if we raise the price too many times? We'll lose all our customers. We can't sell to a negative person. I don't know how to do that. I don't even know what that would look like. Probably icky. Just giving out money. Yeah, that's probably true. We'd probably have to start giving out season tickets. That'd be pretty bad. Yeah, I'll pay you money to come to see my. That would. Whoa, that's not a good way to make money. You see how we quickly start losing money very fast. So when we're asking about this, what eventually happens to the number of season ticket holders as it increases? Well, the number of our ticket holders will eventually go down until it becomes 0. Will our number of season ticket holders ever go negative? No. I think the theater would probably shut down before they would start paying people to go to the show. So our count, so our number of ticket holders, yeah, that doesn't say number, that says something noober. Our number of ticket holders cannot go negative. We can't let that happen. We would just shut down the theater. So we need to determine the constraint. This means we need to figure out what limitations does n have so that we don't go negative in our number of people. Let's think about just our number of people, this 200 minus 10n, and we know that this number of people has to be greater than or equal to 0. It cannot go negative. This is where I'm going to kind of leave you off on your own. Okay, so we've done most of this front page together. You'll start finding a constraint about what our limitation is on the number of price increases. We'll start to figure out what exactly that means for the revenue. Please turn the page with me and see what we also have in store. You'll graph this revenue function. When you do this, keep it in this set of parentheses like we have. We're just going to plug this into a y equal. And you may want to have your table start at 0 and change in table every 1. That'll help you graph it. Bless you, bless you. It'll ask you to interpret key points on your graph, compare it to what you're seeing on your calculator, and then you'll start analyzing it, figuring out when it's increasing and decreasing, what the maximum revenue would be, what that means for their price. Please turn the page with me. We'll also find another way to calculate. See here in the start of part 5, it's asking you to now put it in standard form. So you'll take what we have right now as our 2 sets of parentheses for our function r of n. And you'll FOIL it out. So put a little note here that you're going to FOIL it and put it into standard form. This is just so we can get a different look at it. And then we're also going to calculate the vertex of it. Remember that negative b over 2a vertex thing for a parabola? We're now going to have it, once we have it in standard form, we're going to use that to find the vertex and see if it tells us stuff about the revenue. When you go down to do this table here, it's asking you for that change in revenue as you go through. This is all going to be right from your table. So go to your table for this information, table of values. And when it asks for that change in revenue, it's asking you that change from here, from this number to this number. That's our change in revenue. And then from this number to this number is our change here. What we should be seeing is a couple of changes where the revenue goes up. And then we're going to see that the revenue is going to go down and down and down. All right, so you're just going to compare the 2 previous revenues and say what that change is right there. All right? That last page is asking you just to process some information, 2 big questions, lots of space for you to give some great detail and proof.